Welcome and study with Tanzania Institute of Education.
Welcome to our class. This is chemistry class. My name is Madam Jennifer Kaizlege. I'll be with you into our period studying about our topic is concerning with the oxygen today. We all know oxygen. We breathe oxygen. Oxygen is essential for respiration. Oxygen is essential for the life of living organism. So today we are going to discuss on how we can prepare oxygen in the laboratory. Today we are going to discuss on how we can prepare oxygen in the laboratory. Now, before we go to prepare oxygen in the laboratory, let us ask ourselves a simple question. How does it occur in the atmosphere? Oxygen covers 21%. Oxygen covers 21% by volume in the air. It covers 21% by volume in the air. Now, this is called the ordinary air. This is called the ordinary air. So we need to know how can we prepare oxygen. And later on, we are going to discuss what is the uses of this oxygen. Now, we call it laboratory preparation of oxygen. Laboratory preparation of oxygen. Preparation of oxygen. In the laboratory preparation of oxygen, there are some chemicals which is used, but also there are some apparatus which is also used. Now, before we see the diagrams for preparation of oxygen, let us first identify the apparatus and the chemicals that you're going to use during the preparation of oxygen in the laboratory. The apparatus that you're going to use, we call it apparatus. We have the flat-bottomed flask, flat-bottomed flask, flat-bottomed flask. We should have the delivery tube, delivery tube, delivery tube. We should have the trough. We should have a trough. We should have a beehive shelf, beehive shelf. But also we should have the thesto funnel. Thesto funnel. So these are the apparatus that you're going to be using during preparation of oxygen. But also we should have chemicals. We should have chemicals. This is hydrogen peroxide, hydrogen peroxide. In formula, it is written as the formula for hydrogen peroxide. It is H2O sub 2. This is hydrogen peroxide. And also another chemical that you're going to use is called the manganese 4 oxide. Manganese 4 oxide. This 4 must be under the bracket, manganese 4 oxide. What the chemical formula for manganese 4 oxide? The formula is MnO sub 2. This is called the manganese 4 oxide. So these are the chemicals that you're going to use, but with the assistance of water. So also we have water. These are the most important chemicals and the apparatus that you're going to be using in the laboratory preparation of oxygen. Before we construct our diagram, we need also to know some terms that you're going to be encountering when you are reading your notes or when you are preparing the oxygen in the lab. And what is this? First of all, we have what you call decomposition. We have what you call decomposition. What does decomposition mean? Decomposition is a process of breaking down. A process of breaking down large compound into small element or small compound. You are breaking down. the large compound will be broken into small compound or element. That is the meaning of decomposition. This is the breaking down of large compound into small element or compound. So you are breaking down. Large compound will be broken into small element or into small compound. The other terminology that you're going to meet is what you call catalyst. The other terminology that you're going to encounter is known as catalyst. The question is, what is catalyst? Catalyst is a chemical compound which speeds up the rate of chemical reaction. At the end of the reaction, it will remain unchanged. So by definition, it is a chemical compound which speeds up the rate of chemical reaction, but it remains chemically unchanged at the end of the reaction. So is the chemical compound that speed up the rate of chemical reaction, but remain unchanged. That means does not change. Unchanged at the end of the reaction. The end of the reaction. So the function of the catalyst is just to speed up, to allow the reaction to go faster, but does not take part in a chemical reaction. The catalyst will not take part in a chemical reaction. It's just there to make sure that the reaction is running faster so that it can reach to a completion. But at the end of the day, if you are going to measure the amount you have added, it is going to remain the same. That is why it is known as the substance which speeds up the rate of chemical reaction, but at the end of the reaction, it will remain chemically unchanged. That is the terminologies that you're going to meet. Now, let us see the method used to prepare oxygen in the laboratory. The method used to prepare oxygen in the laboratory. Now we have seen the apparatus and the chemicals and some terminologies. Let's see how do we prepare oxygen in the laboratory. Number one, oxygen can be prepared. Preparation method, we call it method for preparation of oxygen in the laboratory. Oxygen in the laboratory. Number one, you can use catalytic, we call it catalytic decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide using manganese 4 oxide. Manganese 4 oxide. So this is the method number one that you can use to collect oxygen in the laboratory. But number two, it is thermal decomposition. Thermal means heat. Thermal means heat. Heating. So thermal decomposition of potassium chlorate. Potassium chlorate using manganese 4 oxide. So that is another method we can use. Thermal. Thermo means heat. So this reaction will not go to complete, will not give you the product if you don't involve heat. That is why it is called the thermodecomposition of potassium chlorate. So we are going to decompose potassium chlorate in the presence of heat. That is why it is called the thermodecomposition, or thermo means heat. So you break down the potassium chlorate in the presence of heat. And lastly, you can use the compound, decomposing compound, heating compound rich in oxygen. The last, you can use compound rich in oxygen. So also number three, it is called heating compound rich in oxygen. Compound rich in oxygen. Compound containing oxygen. For instance, you can use mercury to oxide. When you decompose mercury to oxide, also you can get oxygen. But among these three methods, the common method which is used in the school laboratory, the common method we are using to prepare oxygen at our school is called the catalytic decomposition of hydrogen peroxide. So the common method used to prepare oxygen, in the laboratory is decomposition of hydrogen peroxide, or catalytic decomposition of hydrogen peroxide using manganese 4 oxide. So this is the common method. And later I'm going to say why. Because this method does not involve heat in the laboratory. We are not using thermodecomposition of potassium chlorate. Why? This method involves heat, which may endanger the lab, either may cause fire accident. Therefore, we are using catalytic decomposition of hydrogen peroxide in the lab to prepare oxygen gas. Now let us see how do we assemble our apparatus, whereby after this you will go to the lab and then we are going to see the actual practical on how oxygen will be prepared. Now consider the following diagram. It is just a simple diagram. Consider the following diagram. This is for preparation diagram for preparation of oxygen gas. This is what you call flat-bottomed flask. So this one, just a simple diagram. So when you are drawing your diagram, make sure you use all measurement required, like a ruler and a coin, so that you can get a good diagram. I'm just elaborating simple diagram. This is for preparation of oxygen, and that is how you're going to so this is the diagram. Okay. This is the diagram. We are going to see what that this apparatus is. Make sure when you are drawing, you draw a very neat diagram. because you can be explaining preparation of oxygen gas just using the diagram. So inside the flat bottom, the flask, there is manganese 4 oxide. Manganese 4 oxide. And this is flat bottom the flask. Flat bottom the flask. This is called the thirst funnel. This is called the delivery tube. This is called the beehive shelf. Inside the trough, there is water. There is water inside the trough. So this one, it is trough. Inside the trough, it is water. This is oxygen gas collected. And this is the gas jar. Gas jar. So what is this? This is hydrogen peroxide. So hydrogen peroxide will be added in the flat bottom the flask. And when it will be added in the flat bottom this flask, it will hit the manganese 4 oxide. Manganese 4 oxide, it is a catalyst used to speed up the rate of reaction. So the function of manganese 4 oxide in the flat bottom the flask is to speed up the decomposition of hydrogen peroxide in order to be able to produce oxygen in another compound. That is what you're going to see in the chemical reaction which is taking place. So now this is a diagram showing how oxygen is prepared using hydrogen peroxide. This is laboratory preparation of oxygen, laboratory preparation of oxygen we are using hydrogen peroxide. Using hydrogen peroxide and the manganese 4 oxide. So this is the diagram. Now, when this hydrogen peroxide will be added, in the flat bottom the flask to react with manganese 4 oxide. But manganese 4 oxide is a catalyst. It does not take part in a chemical reaction. The function is to speed up the decomposition of hydrogen peroxide in order to produce oxygen gas. Now let us see the reaction involved. Reaction taking place. In chemistry, we have 2 ways of lighting the reaction. We have what you call word equation, and we have what you call the formula equation. Therefore, the reaction taking place word equation, we call it equation. How is it written? It is written by hydrogen peroxide. This one will decompose under manganese 4 oxide. Manganese 4 oxide. To produce, this one will produce water plus oxygen gas. My space is a little bit little. Oxygen gas. So by formula, how is it written? It is written H2O2. This one decomposes under MnO2. You can place it up or down the arrow. This one will give water molecule plus oxygen gas. So this is the chemical reaction involved in the preparation of oxygen gas. I guess everyone, we are together on how we have to set up our diagram for preparation of oxygen gas, but when we visit the lab, we are going to be preparing the oxygen gas in actual practical. But when you are setting up your apparatus, this is what is going to be taking place. And so this is the oxygen gas which is given out. This is the oxygen gas which is given out. Now, our time does not allow us, but the next time we are going to meet, we are going to be discussing the method of collecting oxygen in the lab. What is happening? Why do we have water in the in the trough? What is the function of water? Why the water is pulled down and oxygen is collected in the gas jar? We are going to see the method of collecting oxygen gas and why do we use that method. But also we'll be discussing about the physical and the chemical properties of oxygen. And lastly, we are going to discuss about the uses of oxygen. I hope you have enjoyed our discussion. I hope you have enjoyed our chemistry session. Keep on watching. The next time we're going to meet, I wish you all the best. Thanks for listening. Goodbye.